Hello, so today we are going to do problems from weekly contest 342. The third problem is sliding subarray beauty. So basically we have an array of numbers that has n integers, and we want to find the beauty of each subarray of size k. So we get k in the input and we get the array. But what is the beauty of a subarray? Well, the beauty is the x smallest integer. So we get x, and so it's the x smallest integer in the subarray. Now, if we take that number. If it's negative, we want to return it, but if it's positive, we just want to return 0. So we cap it at 0, which basically means we'll return 0 if there are fewer than x negative numbers, because if that's the case, the x1 would be positive, right? Now, if, let's say, x is equal to 4 and the subarray has length only of 2, then we'll return 0 because there is no x smallest integer, okay? So that's sort of the idea. And then the problem asks us for each subarray of size k, we want to return what's that beauty value with this definition, okay? So let's apply it here. So here k is equal to 3 and x is equal to 2. So the first subarray of length 3 is this one. What's the kth x smallest one is the second smallest one. That's minus 3. Sorry, that's minus 1, because the smallest one is minus 3, the second smallest is minus 1. Now the second subarray of length 3 is this one. Now what's the second smallest in this array? Well, that's minus 2. What's the other kth subarray? Well, it's this one. What's the second smallest there? It's minus 2 again. So that's what we returned. So that's the idea. Now a couple of things you can notice here. The first one is n can go up to 10 to the power of 5. And so this definitely means that we can't do a brute force that is O of n squared. But something interesting here is that the values of the array are between 15 and minus 15. Okay, so something to think about. The range of the values is very small. Okay, so let's see how we can tackle it. Okay, so the first thing solution we are going to do is very easy, because we can use a sorted list. So we'll see that solution first. But then there is another solution that doesn't require a special Python data structure that we can also learn how to do. But first I will do a solution with just sorted list. So sorted list allows you to maintain a sorted list. So when you add an element, it gets inserted in sorted order. So let's look at that for a second here. So if we look at add and remove, which are the two things that we will need to basically for us, let's say for this array, right? Okay, so we start out, let's say for k is equal to 3, we will start out with this subarray, right, from 1 all the way to here, because k is equal to 3. Now when we want to add this element, what do we want to do? Well, we want to add it, but we also want to remove the one at position I minus k here, right? Because it's no longer in the window. We move our window each time. And so the operations that we need to use here are add, to add this element to the new window as we move our window, because when we move again, we want to remove this one and add this one. And we want to add and we want to remove. So let's look at, so we already saw that one and we have remove here. So add, it just adds a value, it's O of log n. So even though the array n can go up to 10 to the power of 5, of log n should be fine. Okay, and remove is also of log n. So we could use that both because it's faster. It would be O of n log n if we do this loop with log n, which should be fast with 10 to the power of 5. Okay, so that's the idea here. So the first thing we need to do is create a sorted list, right? So we need to import it first. So to import it, it's from sorted containers in Python, right? If you look here, it's from sorted containers. And so those are what we need. So from sorted containers, we want to import a sorted list. Okay, and now for our sorted list, we'll start out with the numbers up to k. Okay, so this is our window. Then we'll go for the range each time we'll move our window. We start from k because we already took the k first elements, which end at k minus 1 because we are numbering from 0, and then all the way to the length of the array. Okay, and each time we move our window. Okay, so basically this means move window to I, right? And basically means remove the first element in the window, which is I minus k, right? And that's also visible here. So first we start with a window that ends at this one here, and then we add 3, right? So we add 3, so I would be here at 3. And what's the I minus k? Is that 3 minus 3? That's the zeroth one, so we remove it, which is the first one we remove here. And then as we move again, we get to 4 here. So I is equal to 4. What do we want to remove? 4 minus 3, which is 1, which is this one. So it works out fine. So that's what we are going to do here. And so with sorted lists, we know it's log n, so we can just do add the number at position I, and we want to remove the number at position I minus k, right? Each time. But we want to return a result, right? A result of the x smallest one, okay? And so how do we do that? Well, with sorted list, since it maintains the sorted order, we can just, the first thing we can do here is just add window at x minus 1 because we start indexing from 0, and this is window is always sorted. But the problem says we want to take 0. Now we are guaranteed that x is smaller than k, so we don't need to worry. And since window is guaranteed to have length k, we don't need to worry about this being out of bounds. Okay, but we want to take the min, so that because the problem says if this is positive, we want to get 0. Okay, so that's what we are doing here. So we do it for the first window, and then here we do it for each window, and then we return res. Okay, let's run this. Looks like there is small problem here. We return minus 3. Let's see. Sorry, here we want to remove this. So we want to remove the 1 at the start of the previous window, and then we want to add the 1 at the end of the new window, right? So this one should be removed. Now if we run this, looks good. Let's submit. Okay, so that gets accepted. Now what's the time complexity? Well, here the time complexity is, here we are doing O(n) each time we move. And these two operations are each O of log n. So O of 2 log n, which is O of log n. So overall the time complexity is going to be O of n log n. We should be reasonably fast here, okay? Okay, so the other way we can solve this is the problem says that the numbers are between minus 50 and 50, okay? So what this would mean is that the range of the if we were to put these in some place to count the number of occurrences, we only need 101 slots, right? Or even let's say 102 slots, okay? And so now the question, what happens here is that what we can do is we can take our initial array, let's say the one that we had 1 minus 1 minus 3 minus 2 minus 3, and k equal to 3. We can have a counter that counts the number of occurrences. So let's say something like counter like this, where it says 1 occurred once, minus 1 occurred once, minus 2 occurred once. You get the idea, okay? It does it for, of course, each window, right? But what's the advantage of doing that? Well, what we can do here is, if a number is negative, to be able to index it fine in an array, let's have an array here, we need the index to be positive, and so we can just take whatever the number is at I, right? So nums of I, we can just add plus 50 to get its index. But when we are returning it to add it to the result, we can just subtract this minus 50 back. That way they will all fit in this array, and we can index the negative ones. So that's the idea. And so we'll start out with a counter for just the window that we have here. So the window k equal to 3, so we'll just take these and say 1 occurred once, minus 1 occurred once, and minus 3 occurred once. Okay, and now as we move our window to this like this here, we need to remove this element and we need to add this element. So how do we do that? Well, it's easy, because to get the index we can just do counter. What's the index of this element? Well, we know that it's the index, the element in the array is just the number at I minus k, right? That's what we saw earlier, because when you are here, I is here, this is I minus k. And so we just need to normalize it by adding this 50 so that negative numbers can have an index. And what do we want to do? We want to remove it from the count. So we want to say minus 1. And that basically, in this case, when we move, it will say, it will do this minus 1, so it will say this is now 0. And then what should we do for the number that we are adding? Well, the number that we are adding, we just want to, which is at I, we just want to do the same thing, but we want to add it to our window, so we want to say it increased occurrence by 1. Okay, and so now we will say that minus 2. This is, by the way, an array. I'm just adding only the numbers that are present. It's not a map. We can use an array of length 102. So we'll say minus 2 occurred once here. Okay. And now what else happens? Now once we do that window, how do we each time add to our result? Now that we saw how do we fill this this array. So how do we add to our result? Well, for our result, what we want to get is just the number at position x, right? The number at position x, and to get the number from the count, we just take it, right? For if we go through 102, we just do I minus 50 to remove the 50 that we added. So how do we get the xth element in this counter? Well, we know we just go through all the numbers, which are up to, let's say, 102, and we just check if the counter is positive for that number. If it's positive, that means it's there, but we don't know, maybe there are duplicates and there are 4 or 5, and so we need to count how many so far we have in the sorted order. And so we say here, if we find it, we add counter of I, and once this count reaches x, is bigger or equal to x, because it may be bigger than x. Let's say x is equal to 2 and there are 4 ones. Okay, in that case, then when we add the count, immediately it would be 4, which is bigger than x. So we need to handle the case of duplicates. And so here, as soon as count is bigger than x or equal to x, then that means this is the x smallest element in our window, because we only looked at the counter, and counter has the number of occurrences for our window, right? So as soon as this is the case, what should we return? Well, we should return this number, right? Because this is the x smallest one. But as I said here, each time we added it to the counter, we did add 50, and so we need to normalize it back, minus 50, and then we can just add this number to our result array. Okay, and so if we apply this to our case for the first window, when we had 1, minus 1, and 3, to get the x equal to 2, 1, we'll just go in sorted order. So first we'll start with minus 3 occurred once, so our count is equal to 1, and then we'll get minus 1, so occurred once, our count equal to 2, which is equal to x, and so we'll just return minus 1. Okay, and of course here we need to take the min between this and 0, because the problem says we need to, we shouldn't return positive numbers, we should return only negative. And so now in this new window here, now we go again, so that's in the order. So minus 3 actually would be plus 50, so it would be in this counter here. Let's actually just write it down. So 1 would be 51, and then minus 1 would be 49, and then minus 3 would be 40, just 50 minus 3, which would be 47. And then minus 2 would be 48. Okay, so here this would be 48 occurring ones. Okay, and so now, since we go in order from 0 to 102, the first one we reach is 47. Now 47 count is equal to 1. And then we go to 48, now count is equal to 2, so that means the x smallest is 48. The second smallest is 48. And so we do minus 50. So 48 minus 50, that gives us minus 2, so we put minus 2. And then we move to the next window, which is this one, which means basically we need to remove this one, and we need to add this one. So what does that mean? So we need to add minus 1. What is minus 1? Plus 50, that's 49. And so we need to subtract 1 from 49. So we say this is now 0. And then we want to add 3. So we say 3 plus 50, that's 53. And so we want to add 53. So now 53 occurred once. Okay. And then we, now we traverse up to 102. And so the first one we reach is going to be 47. And so 47 count now is equal to 1. And then the second one is 48, so count is now equal to 2. So this one is the smallest, second smallest. And so to add it, we do I minus 50, which is 48 minus 50, which gives us minus 2. And we return this. We are done. Okay. And you can see here what's useful about this is that the adding and removing is of one operation, because we just do minus 1 or plus 1. And then for each iteration, to get this x smallest element, we would have to do this loop, which is of 102, which is constant. Okay? And so that makes it a lot easier. And so let's implement this solution and make sure it passes. Okay, so let's implement the solution that we have now. So instead of using this sorted list, what we'll do is we actually will just use the counter array. Okay, and then we will go for the range of k, and as we said, we will normalize any number we add, so nums of I plus k. And here let's just do 102 to be safe. So this, sorry, plus 50, because that's how we are normalizing it. And so we do plus 1. And then we will need to add the xth one to the array. I will create a function for it to guess the one in the x position. And so let's just define it like this. So this is the function. We'll define it in a minute. But first we need to go through each window of size k, and so we will keep moving by 1 each time. And we'll do exactly what we said for the counter, so I minus 50 to normalize these. So here we wanna, plus 50, we wanna add it because we're just adding this number, and then the one at position I minus k, we wanna remove it because we are moving the window past it. And then we do the same thing on each iteration. We add the one on the x position, and then we return result. And now this one gives us the element in the x position in the window that has that is tracked by this counter. But if that element is positive, we want to return 0. Okay, and so that's what we want to do here. So to do it, as we said, we go all the way up to here, and we want to count how many we have so far. And since we can have duplicates, count is going to add the entire number of occurrences of this number, which is actually just I, not a number at I. And so this is to normalize it. So we are going to add it. Now we just want to add it only if it's positive, because what if the number occurred multiple times, and then let's say we had 1, 1, 1, and 2, 3, 4, and now our window is here, then the number of occurrences of 1 would be negative, right? And so we just want to, sorry, not negative actually, it would be 0 because we'll add it and then remove it. But regardless, in any case, we want to add it only if it's bigger than 0, okay? And so if it's bigger than 0, then once the counter reaches x, that means we reach the x position. So immediately we want to return that number, but we want to remove the 50 that we added here and here. Okay, and so we do that, but we also want to make sure that we don't get a positive number, because the problem says if we get a positive number, we want to return 0. Okay, and then here, just to be safe, we want to return 0. Okay, and that should be it. Now let's run this. And so this route gets us the one in the X position, and this is just each updates for each window here, and then we add the number. So if we submit, should work, and it does get accepted. Now in terms of time complexity, this here is O of k. Now this is O of n, so plus if we add this to this, this is at O of n overall time. Now O of n, but what's in the, so this gets called O of n, but what is inside? So these two are O of 1, so we don't need to worry about them. But what about this x? So this one runs O of 102, so it's constant, and so overall it's O of n time. O of n multiplied by 102, but it should be O of n overall in terms of algorithm complexity. And then in terms of space, we are using this counter, which is also constant space because it's up to 102. Yeah, and that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.